right, so the last talk, I'm the last one standing between you and a mug of beer, probably. So, so let's get started, and I will try to keep it on time. So my name is Kapil Arora. I'm a senior solution engineer working at HashiCorp here in Germany. I work with lots of enterprise customers, solving lots of automation-related challenges in the infrastructure space and provisioning, secret management, and today we are focusing on secret management, and especially in the Kubernetes or container space, how you can solve that, what kind of challenges we face there, and how can HashiCorp Vault really help you securing your Kubernetes clusters. So I've set an agenda for us today. It's not a fixed agenda, but I will try to take you through this journey. We will talk about challenges first. Why are we even talking about secret management? Why do we need to do that? What are the things you need to consider? And who needs to care about it, kind of. Then we will talk about what is Vault, what can Vault offer us, not only in the Kubernetes space, but generally what Vault is. So as an overview, we will talk about Vault and Kubernetes together. Then I will show you two different kind of integrations that we can do with Kubernetes in the Vault space. I also have a demo at the end, so I hope time will permit us to look at the demo as well. And the demo gods will be with me because the demo will be live. So fingers crossed for that. All right, so before we begin, maybe many of you do not know about HashiCorp. So if you do not know, if you look at these tools on the right-hand side, I'm sure you have worked with or heard about one of them, at least Terraform, if nothing else, or Packer. So we are the company behind all of these tools. And if you would have worked with one or the other, you will realize that they are around infrastructure automation. So most of them are around provisioning. If you're using Vagrant to set up developer environments, or Packer to create images for your infrastructure, Vault Boundary around security, and then Console to do service discovery, application networking, and the like. So very focused company on cloud infrastructure automation, and we have all these tools which are open source available for the community to use, explore, and deploy in production. And I have a lot of stickers here. So HashiCorp stickers, all the tools. If you already use one of the tools and would like to grab one, you can come by later and pick up one of the stickers or more of them. All right, so let's talk about or start with the challenges that we face in secret management. So as soon as you have your infrastructure ready and you're deploying your applications need secrets, right? Backend needs to talk to the database, needs database credentials. Service needs to talk to APIs, needs API keys. You need to access files from an S3 bucket. You need cloud credentials. Maybe you also need a certificate, right? So there are always secrets in most deployments. And we see that many times secrets are given out by humans manually. And sometimes we see that secrets are put into configurations and they just stay there, sometimes for years as well. So this is a big security concern, especially if somebody is passing around secrets in communication channels like Slack or emails. And the biggest problem comes when you have one secret to a database, like a database user and password, and many applications are using that. It is really difficult to track if the secret got leaked and which application leaked that secret. So as a developer, maybe you do not think about it sometimes that much, but it can cause or pose your company a lot of threat because secrets give access to data, and data can be something sensitive, which if leaked can cause a lot of problems for the company. So that's why it's a serious problem, and mostly security engineering is always concerned about it and would like to remove as many static secrets as possible and avoid this problem of secret sprawl. So secrets everywhere, do not know where it got leaked, how it got leaked, and how to prevent or take action if it got leaked. Then even if you manage to make sure that you are providing secrets safely to the application, you maybe have a compliance reason or some other reasons that you definitely want to rotate them. And that can be a lot of operational overhead. And sometimes people forget that or are not able to manage that effectively, right? So it's something which is challenging, and many people face that problem. And then you have to provide access to different systems like clouds or SSH access to machines. You want to make sure data is encrypted, or the secrets are also encrypted whenever stored, right? And then you have different platforms, different clouds, Kubernetes, Docker, Azure, AWS, and you have to do the same problem and solve it everywhere somehow in the same way. And then everything should be audited. You should be able to know when something got leaked, how it got leaked, what should I do if it gets leaked, right? And how I can prevent my company from facing any challenges if something gets leaked. So these are really serious concerns and can cost a lot of money. And to prevent these costs, to make your workforce productive and to provide scalability in the environment, you definitely need something which can centrally manage your secrets. You can centrally audit everything and then provide a secure way, a standard way for everybody to manage secrets and at least have some transparency in the organization. Otherwise, we have no idea who's doing what, how they're handling secrets. Then it's really, really tough to get a control over that. So I hope it gives you an idea why secret management is so important and why we have to solve this problem. If not as developers, as organizations, we definitely have to address it. And that's where HashiCorp Vault comes into the picture. HashiCorp Vault has been around since 2016, and it has become a really, really popular open source tool and also an enterprise tool for different organizations. Banks, financial institutions were the early adopters of this technology. I personally also work with many banks in the region who are using Vault and using it as a central system to manage access to all kinds of secrets. So that's kind of the main or first use cases that Vault came up with or started as. And then we also added more things like, you can do encryption as a service with Vault. And there are some advanced use cases like KMIP, key management, or cloud key management, and database encryption. But it's mostly around protecting sensitive information like secrets, and secret management is kind of where most customers start their journey with Vault. Highly scalable application, because it has to be a central system. It has to scale, right? It has to be something which has to be always available, because if secrets are not available, then nothing is available. So everything goes down. So that's why we need a very highly available, reliable system. So which Vault provides, and great scalability. Adobe uses Vault with 2 trillion transactions per week. So a proven platform for scalability and very popular in the open source space. So our websites see millions of downloads every month, and it's a really good product for all kinds of people, so practitioners, enterprises, and we see the popularity when we look at the downloads, and when we look at reports like this one from Datadog, where Vault is now the top 10 container. So it's a very popular container as well, not just a product. All right, so Vault has a very standard workflow, and all technologies or all kinds of use cases can be covered with this workflow. And I will use this diagram or this slide to kind of explain that workflow. And let's take the example of Kubernetes itself. So Vault has these 3 participants, or a triangle approach, where a client, which you can think in Kubernetes as a Kubernetes pod, needs access to a secret or a system or a database or credentials to cloud or something like this. So that's kind of the second participants. And there we have a plugin architecture where you can have different plugins like cloud plugins, or you can have database plugins. And all these plugins can provide short-lived dynamic credentials. So that's kind of the really plus part of Vault, that it can integrate with different systems and can generate credentials when they are required. So that's kind of how it plays differently than other secret managements. And then on the left side, we see a lot of auth methods, what we call them. So if a client wants a secret, so if a pod running in Kubernetes wants to access a secret, the pod must have an identity to prove itself that it has access to something. And in Kubernetes, we can use the Kubernetes Authentication, so the service accounts, to prove that identity. So once the identity is proven, then based on if there's a policy written for this pod to be able to access secret, then it is able to get a token, and with this token, it can fetch all the secrets that it has access to. And this applies to all kinds of systems and all kinds of clients. So if, say, there's a VM running in Azure, it could have a system assigned managed identity, which is given by Azure. And because it has this identity, it can get access to blob storage or S3 bucket or a database credential or whatever we give it access to, right? And that too dynamically. So that's kind of the workflow, and it remains the same. It doesn't matter which client, which secret, and which identity. So Vault acts like an identity broker and is able to provide that. And the same concept we will use today in our Kubernetes demos or concepts to understand how we can do the same thing in Kubernetes. So your application could be running in Kubernetes, Azure, AWS. It could fetch the secrets with its own identity wherever it is running, doesn't matter. And you can have this standard within the organization, right? You do not need to change where and how the secrets are stored. All right. So now let's talk about what does Vault do with Kubernetes, right? So there are lots of different aspects to that. The first one is that you can deploy Vault within Kubernetes or use Vault within Kubernetes. For that, we have a Helm chart, which can be used in most Kubernetes distributions. Also OpenShift, for example, it is certified for that. And then we have an authentication method, right? So we can use different authentication methods, and Kubernetes is one of them. So that's why we can integrate with applications running inside Kubernetes. Then we can use the Kubernetes mutating webhook technology to inject sidecars, which can take care of fetching the secrets for us, right? So that's something we integrate with, which is also quite nice. And the last one is there is a Csi secret store plugin or driver, you can call it. And we have a plugin into that. So you can also use Csi to provide secrets within a volume or within a secret, Kubernetes secrets itself, right? Kubernetes secrets is also an option which many people use in Kubernetes, but then you have to actually create them. You have to provide the secrets in a YAML file maybe, and then you need to rotate them. So they are not, and they are stored with base 64 encoded, so they're not that secure. So you have to take care of how you're going to protect them and rotate them. So it is a lot of overhead, in my opinion, and not the best and most secure solution, especially if you have more different platforms in your organization. All right, so this is kind of the overview of what all exists. I will just go through these slides, and then I think we will come to the main point of today. How can you really build applications or use Vault for your applications? But I will just brush through quickly some of the slides in 5 minutes, and then we will come to the point of looking at some examples and the demo. Yeah. All right, so Helm chart for ease of deployment, provide templating, versioning, upgrading Vault within Kubernetes and stuff like that. So important part of any Kubernetes application which runs on Kubernetes, some resources. Vault is very developer friendly, so there's a dev mode. So I actually use it on my laptop, and you can quickly get started and start using Vault. Because it's a security system, there are lots of complicated scenarios, how you deploy it in production. You have to protect the storage and stuff. So you can, as a developer, quickly get started. You do not have to worry about complicated things. So which I find personally very good. And all HashiCorp tools are actually delivered just as a binary, which you can start on your laptop, which I find also very, very compelling for developers, especially. All right, so the second part is the Kubernetes authentication. You can define, you can connect Vault to not just one, but multiple Kubernetes systems, and you can define how the authentication will work and kind of define roles. So for example, I have an application which has a role like database, and the role can be assigned to a service account, and you can assign that to multiple service accounts. So that's kind of how you associate that, and we will look at that in the demo as well. We also provide security considerations, reference architecture as to how you can deploy a Vault in Kubernetes, which is also really, really important resources. This is a sample deployment, how you would deploy Vault in your environment if you are full Kubernetes shop, for example. So you would maybe have a special cluster where you deploy security tools, and you will deploy Vault as a stateful set. And then you could integrate Vault with multiple different IAMs or identity systems like Okta, Azure AD, GitHub, whatever you have available. And then there are concepts of, encrypting Vault storage. You can use any KMS like Azure Key Vault or AWS KMS to protect the master key for Vault. Then you can use different blob storage S3 file to take backups. And then you have configuration for dynamic secrets. So that's kind of how it looks. And then you can have multiple application Kubernetes clusters, which could use Vault to store all the secrets. And Vault will be responsible for storing securely, encrypting, providing only access if the authentication happens, and also providing these dynamic secrets to different Kubernetes clusters. All right. So so far, so good. Let's talk about the integration with Kubernetes as to how does an application running inside Kubernetes get access to the secrets, right? So this method, which is called agent sidecar injection, is very good for applications which are not aware of Vault at all. So I, as an application developer, I could write code, talk to Vault APIs, fetch my secrets, right? Many Java developers do that. We have really good integration into Spring Boot, for example. But many times you have older applications which cannot do that. And many times these secrets are written inside a config file. So what Vault can do is, just by using annotations, we can, and templating, we can provide this agent sidecar injection. So when you define your pods or deployment, you will just write annotations and define, yes, I want sidecar injection. I will use this service account, and I have this config file in which the secret should be present when the application runs. And Vault can do all that using the Kubernetes auth method. So this is some examples of how it looks. So when you start you write your YAML for your application, you will just provide these annotations. I want agent injection true. And you can provide the configuration file where the secret should be stored. And you can also write a template like this. So if you see here, with secret, which is stored at this path, put the username here and the password here. So it means that when the application or the sidecar container starts, it will automatically talk to Vault, create this config file with this information, and put it on the file system, and the application will have access to the secrets. So that's kind of the whole point. So when you deploy this application, only thing you have to do is install Vault, provide all the rules and roles that you want to provide, and then just deployment-wise, you just give annotations as to which secret should be populated where at the end. So that's how the agent sidecar injection works. And now let's talk about the other way of providing secrets, which is more maybe standard, or lots of people are already using that, using the Csi interface, right? So Csi, probably many of you know, is container storage interface, which can help you mount block storage or other types of storage within your Kubernetes pods as volumes. And there's also a possibility to use that for secrets, right? And that is available as an open source project as secret store CSI driver. And it allows us to mount secrets as volumes within Kubernetes. There are more features, like you can sync that with your Kubernetes secrets. So it will automatically create secrets for you in the Kubernetes definitions or YAMLs. So you can also provide that. So we plug into this CSI plugin, and we add Vault as part of that. So you can define a storage class, I will show you, and Vault integrates into that simply. I think, yeah. So those were the two methods. And now what I have prepared is I have prepared two examples. One is a demo, and one is just how the functionality works. So the first one is how does the agent sidecar injection work if I have, say, a .NET application? What would be my approach, and how would the secret be available? So I have some diagrams to show. And then the second one is just how the CSI integration looks like, and that we will do as a demo. All right. So we start with a .NET application and a SQL database, right? And this is deployed, say, in an AKS in Azure. And you have a file called appsettings.json in which the database connection string is present. So if I put this in a config map, right, it's a static configuration. How will I change it? When will I change it? If we have no idea, then we have a problem, right? Because we need to update this file and rotate the credentials of MySQL database. So we want to solve this problem with help of Vault. So first thing I'm doing here is showing you how the appsettings.json look. So it has one connection string part which defines the username password of the database, right? So now I have a definition of my settings file. I have to think about how I can solve it. So how this will work is that we will have a Vault agent sidecar which will be responsible for updating this file. This will talk and authenticate to Vault server. Vault server will fetch the SQL credentials, which are also dynamically generated for this application, and populate this file, right? So once everything is set up, the credentials are automatically populated. You do not have to provide any configuration. And when the lease is expired for this credential, then Vault agent should automatically update this file as well. So that's kind of the expectation. All right, so the template looks like this. So I have the JSON file, but the template will have these markers to tell the templating engine that this is the part which needs to be populated with this secret and password. So that's the template. And important part is also that what happens when my application settings changes, right? I need to tell my application that the settings changed. So in .NET, we have provisions to reload the application or do something when this file changes, right? So this is a good part in .NET which can be leveraged. So reload on change, right? So this can be used. And then on configuring, you can then reset your database connection. So it means that .NET itself has functionality to know when the file has changed and then reset the database connection, which works really well in this case. But for other language, maybe there are other ways to do that, or you need to somehow provide a command or automatically set that the pod should restart if you know that your database expires after 1 week, for example, right? So we have to think about that, but it's an important part because once the database password changes, the application should be able to reload somehow, right? So these are some of the annotations I wrote for this application. So you can see here, I'm injecting and providing. So the whole configuration is just annotations and nothing else. That's also very, very important part of it. So how this will work is now I will have an init container because I would like the application to start, but when the application starts, it should already have the database. So that's why an init container is definitely required. And then a sidecar container will keep running. When the database password changes, it will update the file. So initially, it will authenticate, fetch the passwords of MySQL, and then populate in the file. And then when it when it has to update, the sidecar container will talk to Vault and fetch the SQL password and update this file. So basically, that's how agent injection will work for a .NET application. And once you have set this up, no need for password rotation. Depending on when your password changes, automatically the file will be updated. And you can go ahead and not worry about password rotation. So even if somebody reads this app settings.json, after a while, the password will be changed anyway. All right, so the second one is the demo with the CSI secret store. And I will now go into the demo part. Is it big enough? Yeah, okay. All right, so I wrote some scripts here on the left-hand side, so we can just run through the script. So what I'm going to do is I'm going to go away. Just use Helm repository from HashiCorp to install Vault. So let's do that. And as a second step, I installed MySQL database. You can see the CSI provider is also running. So as part of the Helm chart, I can provide that CSI should be enabled. So it will automatically start this container to take care of the CSI operations. Then I'm going to start MySQL. So I'm using MySQL here to show you that the application will get updated passwords automatically, right? So that's kind of why I use MySQL here. So MySQL is running now. I'm also going to create a static secret. So Vault provides dynamic secrets, but you can also have static key value pairs, which can be versioned. And that also can be provided to the application. So just some random secret. Now this is an important part, right? So I'm connecting Vault to my database. So in Vault, you have to enable secret engines, and database secret engine is what we are using for MySQL. And then you configure it. So I'm providing it. It says root username password, but you can provide it just the username password, which is required to create new users. And I'm providing it with the URL and things. And then you can also rotate the password that you provided it. So it means that this password and username can also be rotated immediately. So a human has seen these username passwords, but we do not want that. So immediately after this configuration, this username password will be invalidated. And then I've created some roles, and these roles have a query to create a user. It means if a user has this role, Vault demo app long, it will get a new user created using this SQL statement, and it will be valid for 1 hour. So this defines how long a secret will be valid when it is generated by Vault. And then I have one which is even shorter time to live. It's only valid for 2 minutes, and we are going to use that one to show you that 2 minutes, and then the secret is regenerated. And I'm just taking an example here to generate the secret. So you can see a new database username password has been generated by Vault talking to MySQL database. Yeah. Then I configured the Kubernetes part. So we have connected to a database, which is the secret, but we need to connect to the authentication method. So when you deploy Vault, it is creating this service account, which can be used to create or provide the authentication within Kubernetes. And I'm just using the JWT token and certificate provided inside this service account for Vault. And I'm just providing it and sending it to Vault so that Vault can use this identity to talk to Kubernetes. So let's do that. That is done. And now this is also important. So we have an authentication, we have a system, but we have to say if an application with a particular service account wants to get credentials, it should be allowed to get credentials. So I'm creating a database role and saying this should be the service account, and it should have this policy. And this policy will give access to the database to read these credentials. So policy is also an important part because it's providing the authorization, right? So let's do that. And then we install the CSI driver, which I haven't done that yet. And then to provide these secrets inside my pod, I need to create a secret provider class. So these are running. And this secret provider class is kind of where I define where is my vault and which secrets do I want inside my pod, right? So I want my database password, username, and the static password, and this is my vault that needs to be used. And I'm going to create this class. This is created, and now we are ready to deploy our pod, right? So I have a web app, which is using this volume, right? So the secret store class that I created, we will mount it as a volume, and we will mount it at this place. So we can deploy this application now. No. So web app is running already. So it means that this web app should be able to read the MySQL username, password, and the static secret. And for that, I wrote a quick test. And you can see, quickly. So what I'm doing is I'm going inside the container. I'm reading the contents of where I've mounted the secret, right? And I can see that username password was generated specially for this application, but they are only valid for 2 minutes. So after 2 minutes, we are waiting for the credentials right now. After 2 minutes, this is going to be new credentials and also automatically updated and mounted on the file system of the pod. So it means that every time you can set how long you want the secret to be valid, and then after a week, after 5 minutes, after 1 year, the secret will automatically be available inside the pod. Nobody has to rotate anything. Nobody has to provide manual configuration anywhere. It should just ideally work once you set it up, right? So we have to wait for 2 minutes to get this, and I think it's a good time to just summarize. So we saw that Vault has a really tight integration to Kubernetes. You can install it there. You can also use an external Vault. You don't have to install definitely inside Kubernetes. You can do centralized secret management, not just for Kubernetes, but lots of different things. It acts as an identity broker, so you can have all kinds of identities used by Vault and fetching secrets of different systems. Also offers encryption service, which we don't look at today, but for another day probably. And Helm chart, agent injection, CSI driver is what we looked at in the talk. So we can just leave it on the screen. When 2 minutes are over, it will have a new username password. And I'm happy to take any questions if you have. So that's perfect timing. So you can see this, this username is different from this username. I'm basically reading it from the file system, right? So you can see the new password is generated and automatically available inside the pod of our volume. So it will work the same way with the injection, just that you have those templating and stuff like that. That's it.